So now let's talk about model software, meaning NERPMAB. What are different tools and software and technologies that's used in NERPMAB? So unlike a trip-based model, an activity-based model deals with multiple software and technologies. So if you have a trip-based model, pretty much everything happens within Visum. You know, the trip generation, distribution, more choice. All those steps, they happen within Visum itself, and normally you do not deal with any other software technology other than Python, which is inbuilt within Visum. But in case of an ABM, normally the core ABM engine itself is a different software, and then there are also a lot of dependencies to ABM. So every ABM works. It's pretty much an agent-based simulation, so it needs a synthetic population of persons and households. So ABMs generally require a population synthesizer, and then there could be very specific input data needs for ABM. So there could be other dependencies or softwares that create those custom inputs for ABM. So we'll go through what are various softwares or tools that you would come across when working with NERPMAB. So to get an idea of what different tools are there in NERPMAB, you can go to the model setup and look inside the tools directory, and you would find all of these subdirectories within the tool directory. So first is you would see a folder called population synthesis. So this directory houses population sim, which is a population synthesizer. We'll talk about that a little bit more in a bit. And then you would find Dacing data tools. So NERPMAB uses Dacing as its activity-based model. So Dacing data tools are complementary tools that prepare land use inputs for Dacing. And then in that folder, you would also find a subdirectory for Dacing, where all the software and files related to Dacing are stored. And then Dacing also comes with a reporting tool. Once a ABM run is complete, the Dsm Reporting Tool creates various summaries for calibration and validation. So that is also another tool that you would find in this tools directory. And besides these, there are two other folders which are one of which is a JDK, is a Java install, and then there is also an R install. So for NERPM, working with NERPMAB, you don't have to install any third-party software. You just, as long as you have the latest version of Visum, all the other dependencies are included in the model setup itself. So if a tool requires Java, then Java install is included in the model setup. If an R script needs to be run, then R install is included. And so this is just to make the model user friendly, because many a times configuring if a model requires multiple software or technologies, then it becomes very cumbersome to install and configure the model. So everything is included in the model setup, so you don't have to install any other third-party software. But we'll walk through these tools and just to get you an idea about which tools use which technology. Okay, so and then the main software in NERPMAB is PTV Visum, and PTV Visum along with the Python API is the main software for NERPMAB. It serves as the GUI for all modeling tasks. So as I mentioned before, it sort of one-stop shop for all your needs. If you want to edit the network, if you want to change any of the inputs, if you want to change the flow of model, for all those tasks, you would always go to the Visum version file. So Visum also provides you scenario management. There are multiple ways of doing scenario management in Visum. You can create a separate version file for each scenario, or within Visum itself, there is an inbuilt scenario management feature, and we are not going to cover that, how to actually do scenario management today, but we did cover that in much detail in one of the previous trainings. So you can go back and refer to the training materials from that session to learn more about it. But besides scenario management, all demand models, network models, everything is implemented in Visum, and the using all the inbuilt algorithms in Visum, or using the Python API and running a Python script. So Visum, by means of a procedure sequence, it controls the model flow system, and it sort of integrates all the other tools. It provides the Visum Python API provides an interface to connect with other third-party tools such as Population Sim or Dacing, and so Visum integrates all the model components together. And as I mentioned before, NERPMAB requires the most recent version of PTV Visum and the most latest service pack. Okay, so the next tool is Population Sim. So for those of you who do not know, Population Sim is a population synthesizer. It was developed in Activity Sim framework. It runs on Anaconda distribution of Python. The purpose of Population Sim in NERPMAB is to generate a synthetic population for Dacing. So as I mentioned before, every ABM requires disaggregate synthetic population. So you can use Population Sim to generate that, and NERPMAB makes use of Population Sim to generate those inputs for Dacing. And this is where you would find population synthesis, Population Sim in your model setup. So go to Tools directory, and then go to the Population Synthesis folder here, and you will see this kind of a directory structure, which is typical of Population Sim setup. And let's go through some of these folders. So as I mentioned, Population Sim requires Anaconda distribution of Python. But again, you need not worry about installing Population Sim or installing Anaconda. All the dependencies are included in the model setup itself. So the model setup comes with a full Anaconda install at this point, and whenever a Population Sim is called, it calls the executable that it needs from this full install of Anaconda. And then there is a configs folder. So we are not going to go into how exactly to configure Population Sim, but if there is a need and you want to look at Population Sim settings or anything, this is where you would go. You would go to the configs folder, and it has settings files there to specify controls, and if you want to change any other settings, the format of the outputs or anything, there are settings files that you can configure to do all of that. And then the Population Sim setup also includes data, and it includes data for 3 years. So the data folder, that's for the base year 2015, and then there is also data for 2030 and 2045 models. and you can you know the main inputs to population sim are a seed sample, which is pumps data, and marginal controls. And so we have that data for all 3 years, and all of this is run automatically, so you don't really have to worry about where the data is or where the settings files are or where the scripts are. All of this is completely automated, and you don't really have to worry about this when working with NERPMAB maybe. But this is just for your information. If you want to learn more about this, or if you want to change anything substantially, then you should know where to come and where to change the settings or where the data is. And population sim has a nice wiki online that you can refer to if you want to learn more about population sim, or if you want to configure population sim in any way, then you can always do that. Okay, so I think before we go to Dacing data tools, let me just quickly walk you through where you would find population sim. So this is your directory structure, and if you go to tools, you would find all the folders that we talked about. And if you go to population synthesis, this is where you'll find the directory structure for population sim. And Anaconda, again, that's the Anaconda install and configs. If you go to the configs, there's the settings.yaml and controls.csv. These are the settings file for population sim, and then inside the data you have the seed household and seed person file, and then you have various control total files. So, and you need not worry about this run population Python script. This is automatically called from within Visum when population sim need to be run. And there are also scripts to convert population sim outputs to specific format that Dacing requires it in. So that's all about population synthesis. Let's go back to the slideshow. So the next tool that we are going to talk about is Dacing data tools. So Dacing requires various inputs. I would say the three main inputs to any ABM or Dacing is it needs a synthetic population of persons and households, and then it needs land use data, and it needs skims. So Dacing data tools prepare the land use data for Dacing. And Dacing, it's an activity-based model. It operates at a disaggregate level. So in NERPMAB, there are two geographies. Normally in a trip-based model, you have just one geography. You work at the traffic analysis zone level, TAZ level. But in case of an ABM, you might have multiple geography to take advantage of the disaggregate structure. So in NERPMAB, we have traffic analysis zones, and then within each traffic analysis zone, there are also what are called as micro analysis zones, or MAZs. And to fully take advantage of the disaggregate structure of an ABM, Dacing relies on these Dacing data tools, which is a collection of three subtools. There is a network tool which prepares an all-street network, and then there is a DTA tool which computes node-to-node skims. And then there is a buffering tool which generates buffered microzone data, using this all like disaggregate data to create buffered land use data. So Dacing, instead of simply using land use data for each zone, it looks at not just that zone but also the zone surrounding that zone, and it gives you a better idea of the demographics in a neighborhood or the land use data of the neighborhood instead of pointing only at a specific small micro analysis zone. So these three tools, they run in this sequence. It starts with the network tool, and then it goes to DTA Lite, and then to the buffering tool. And you can find Dacing data tools in this directory. You can go to tools and then Dacing data tools, and there are a lot of files, but in this Dacing data tools subdirectory. But you will find three application files which correspond to each of the tools. So the source code for any of those tools is not available, but you have these application files which run the tools. Okay, so before I get into Dacing, let's also quickly look at Dacing data tools here, and let me just order these by type here. And these are the three application files that we were talking about, the buffering tool and DTA Lite and then network prep. And there are, settings file for each of these. Again, for normal operations of NERPMAB, you would never have to, come here or change any of this. But again, this is for your information if you're interested, and if you if you are changing the models significantly where you have to actually make changes, then this is where you would come. And so this .ctl file, this is the settings file for the network data prep tool. And then there is this XML file, which is again, for three different years. And if you open that, that's the configuration file for Dsm buffering tool. And here you can define things like buffer distance and other parameters if you want to change the name of the file or anything. But again, you need not change any of this for normal operation. And then this Dta Settings.ini is where you would find specific settings for Dta, which again need not be changed for normal use of the model. Okay, so let's keep going here. In the interest of time, the next tool is Dacing. So Dacing is the core demand generation engine in NERPMAB, which generates the residential demand disaggregate residential demand. And activity-based models, they are developed in different frameworks. So there is a CTRAMP family of ABMs, there is ActivitySim family of ABMs, and Dsm is another popular framework for developing activity-based models. And NERPMAB uses Dsm framework for activity-based model. And again, the source code is not included, but compiled executable of Dsm is included in the model setup. And Dsm simulates travel for a 24-hour period for the entire synthetically generated population of travelers. And if you want to, let's quickly look at where you'll find Dsm. Again, go to the same tools directory inside the Dsm subdirectory. So let's quickly go there and level up and Dsm. And again, there are a lot of files in this folder, but you need not worry about these. All these files, they are just part of the Dsm software, and usually you don't have to worry about this. But these are the two application files which sort of run Dsm. And then Another important folder that you might want to note is the coefficients folder. So let me quickly look at this. So for anyone who is familiar or know anything about ABM, within ABM there are a lot of models that are implemented in a certain sequence. So usually it starts with an auto ownership model, and then you have work location choice, you have tour frequency, mode choice, and so on. And each of those models, they um, are essentially multinomial logit models, choice models. And if you would for, let's say, for example, mode choice model, if it's a choice model multinomial logit, it would have coefficients. So this is where the coefficients for all those models in Dacing are stored, um, and these are stored in this specific F12 file format. So for example, you decide to calibrate NERPMAB, and when you want to add calibration adjustments to your model. So this is where you would come and update the coefficients. Let's say if you want to calibrate the mode choice model, and if you want to adjust the alternate specific constants for maybe the auto mode, then you would go look for the tour mode choice. Let's say if you want to do it for the work purpose, you would go to work tour mode coefficients file, and update the coefficient value accordingly, however you want to calibrate it. And again, this file, coefficient names, everything, it's not very intuitive, but you can always go to Dacim's online wiki, where you can find more information about what exactly those coefficients are, and the description of each coefficient. But the scope of this training, we are not going to look very deeply into how to calibrate Dsm or anything like that. But this is just for your information. In future, if you want to change anything, you can come to this folder, and this is where all the coefficients are stored. Okay, so let's go back here to the slideshow. So that was Dacim, and then there are also Dsm Reporting Tool. So once Dacim has run, the Dacing Reporting Tool takes all these the outputs, the various outputs that Dacim produces, and it processes those outputs and generates various summaries. And then it requires reporting tool. It's nothing but it's a collection of R scripts, so it requires a full R install and also Java to connect with Excel spreadsheets. And the Dsm reporting tool is also in the tools directory, and let's quickly look at that. So let me go up here and Dsm summaries, and this is where you would find all the files relating to Dsm reporting tool. You have different various R scripts to process different models in Dsm, and then there is a bunch of survey data. And let's say if what does it produce in the end? So I have a fully run model here, and we can let's quickly look at what it produces. We'll go through reviewing model outputs in tomorrow's session, but this is just to give you a quick overview of what Dsm reporting tool produces. So it produces these Excel files for different models, and it has various summaries, such as triplet frequency distributions, and all of the summaries that are useful for model calibration and validation. Okay, so I think that was all about all the various tools that are there in NERPMAB, and how to access them, their setting files, or how to if you want to configure them in any way. So